Hello student, good morning. I am Dr.A.K Sinha, Professor of Chemistry. Today I am going to discuss equilibrium constant from Nernst equation. Last two class I have discussed about the Nernst equation. Now I am going to discuss equilibrium constant from Nernst equation, means derivation of equilibrium constant from Nernst equation. This relation is very important for all examination, for all competitive examination, university examination, board examination, everywhere. This is very important. Quickly you will understand. Suppose you are in a Daniell cell. Daniell cell, what is the chemical reaction you are understanding? Zn solid plus copper ion, means cupric ion. It gives Zn ion plus copper metal. This is the equilibrium. This is the, you can say, chemical reaction in Daniell cell. Okay. Zn plus Cu plus means cupric ion, and it will give the product Zn ion plus copper metal. Okay. Now here this experiment, if you will observe in this experiment, means this is actually cell. This is becoming a galvanic cell. Then what will you observe here? That when reaction will take place, when reaction will start, cell is, suppose it is working, then this reaction will take place. Zn plus copper ion, it's cupric ion, and it will give Zn ion plus copper. This reaction takes place, and at the same time what will happen, that is important. And as the time passes, the concentration of Zn ion keeps on increasing. Already I told you that Zn ion dissolves and Zn ion concentration increases, while the concentration of copper ion, means cupric ion, keeps on decreasing, because cupric metal will convert to the metal and it will stick to the copper rod. In copper rod it will stick there. Then copper ion is converted into the copper metal and sticking on the copper rod. That's why copper ion concentration will decreases. Means copper ion, cupric ion, Cu2 plus keeps on decreasing. At the same time, voltage of the cell as read on the voltmeter keeps on decreasing, because this copper is decreasing, copper ion concentration is decreasing. As the reaction will proceed, then slowly that voltage will decrease, and after some time we can observe that there is no change in the concentration of copper ion and Zn ions, because they are maintaining equilibrium. Up to a certain stage, their Zn ion concentration will increase, copper ion concentration will decrease. Okay. Then this I will observe that after some time there is no change in the concentration and zinc ions, and at the same time voltmeter gives 0 reading. No voltage is going to be produced, 0 it is showing. This indicates that equilibrium has been attained. 0 means voltage is 0. It means equilibrium is achieved. Means at equilibrium position, voltage means E cell will be 0. E cell will be 0. Then now you know that E cell is equal to a standard E cell minus 0.059 divided by 2 log base 10 Zn2 plus molar concentration of zinc ion divided by molar concentration of copper ion. Zn2 plus divided by copper 2 plus. Correct? This relation you know. Or full-fledged also you can tell that is the E cell is equal to E standard cell minus 2.303 RT divided by 2F. 2 is the number of electron log base 10 concentration of Zn ion divided by molar concentration of cupric ion. This is the relation. Now according to the experiment you have seen that here you have seen that at equilibrium position E cell is equal to 0. E cell is equal to 0 you have observed. Then in the place of E cell you write 0. Then 0 is equal to a standard E cell minus 2.303 RT divided by 2F log molar concentration of zinc ion divided by molar concentration of copper ion. Then now that 0 is equal to this, then now minus term you bring left side. Then what you will get? E cell is equal to E standard cell is equal to 2.303 RT by 2F log concentration of zinc ion divided by concentration of cupric ion. Correct? Then now E standard you calculated because E cell was 0, hence minus term 2.303 RT divided by 2F log concentration molar concentration of Zn and copper you have brought left side. Then E standard cell is equal to E standard cell became, or you can say E standard cell is equal to now 2.303 RT divided by 2F log concentration of zinc ion divided by concentration of cupric ion. This is the situation at equilibrium. Okay. And here one more things you should remember, you are knowing that this Zn ion concentration divided by copper ion concentration that is equal to Q quotient. Here at equilibrium position it is called K also. It is also called K, dissociation constant, that K. Now you can write for this term for Zn molar concentration of Zn divided by molar concentration of copper, you can write K, means now it will become log K. Then full equation now became that standard electrode potential is equal to 0.059 divided by 2 log Kc. Okay, this is Kc is the equilibrium constant. Here K you are writing C, Kc is the equilibrium constant, C means constant. And this K, when dissociation was going on, then we were telling dissociation constant. If it is for acid, then you were writing Ka. If it was dissociation for base, then you were writing Kb. But here that is at equilibrium position. Now this value is constant. This K is constant. Then for this constant you are using the word C. Then this constant is called equilibrium constant because at equilibrium position this value is there. Kc is the you can say equilibrium constant. Name itself is equilibrium constant, means whatever value is there, this value is fixed. As for example, in this case, in Daniell cell, or you can say Zn copper cell, its value is actually experimentally it is determined 1.1 volt. Means here Kc is equal to 1.1 volt, means log Kc its value is 1.1 volt. Okay, then you can write like this also, that a standard Ecell is equal to here you are knowing the value of log K 1.1 or you can say these things direct. If you want to want relation, if you want a direct relation, means now you are knowing that a standard electrode potential is equal to 0.059 divided by 2 log Kc, and this entire value means 0.0592 V means volt, 0.059 volt divided by 2 log Kc, its value is 1.1 volt. Correct? Then now if you want this, from this relation log Kc, if you want know the value of log Kc, then easily you can calculate, because Ecell standard is equal to 0.059 divided by 2 log Kc. Then what will be the log Kc? Then simply you can calculate by simplification, and then you will get log Kc is equal to, you will get 2 into standard electrode potential divided by 0.059. Okay, just you will by arranging you will get it. Then 1.1 means for entire value I told you it is 1.1. Ecell value is 1.1 volt. Then Ecell into 2, and Ecell value is 1.1. Then 2 into 1.1 volt divided by 0.059. Means now all values are knowing. If you will solve, it will come 37.288 you will get. That is a value of log Kc. But if you want to know the only Kc value, then what you have to do? Then you have to anti-logarithm you have to use. Kc is equal to anti-log of 37.28 anti-log. Then its value will come 2 into 10 to the power minus 37. And the temperature you must write. Suppose this temperature was done at 298 Kelvin, means 25 degrees centigrade. Correct? This is the experimental value. You have written 1.1 volt. Okay. Then here you have seen that you can get the log Kc value. Then directly log Kc value you can by relation, this relation you can get it. And in general way, how both are standard electrode potential and log Kc, how both are related, then now you are knowing that standard electrode potential is equal to 2.303 RT divided by NF log Kc. This is the actually relation between Kc, that is a chemical equilibrium, and Ecell. This relation is very, very important, because Ecell value they will give you in examination. All value they will give. R value is fixed. T will be generally fixed also, 298. N may vary. F again will be fixed, means 0.059, that is the fixed. Only N divided by N, that you have to, by reaction you can know. If number of electrons which is taking part in the balanced equation, how many electrons are there, 2 electron, 3 electron, 1 electron, that is the, accordingly you can write, if n is equal, electron is 1, then n is equal to 1. If electron is 2, then n is equal to 2. If 3, then n is equal to 3. Then this is the actually relation between electrode potential and chemical equilibrium. This relationship between equilibrium constant of the reaction and standard potential of the cell in which that reaction takes place. Okay, this is the equilibrium constant of the reaction. It is actually difficult it is very difficult to measure. Now it can be calculated. Equilibrium constant actually is very difficult to measure, but now it can be calculated from the corresponding standard electrode potential. If you are knowing the standard electrode potential, then all value are knowing, 2.303, R value are knowing, T value are knowing, F you are knowing, N only you have to know by reaction. Then log K you can calculate, and when log Kc will calculate, then Kc value you can get it by anti-log chart. Okay. Then this relation always you remember. This is very, very important relation and very useful in solving the numericals. Then on this again numericals will be very easy. If you are knowing the this relationship, if you are knowing, then what is the problem? In solving, what only this value, all value will give, quickly you can get the this. If K value they will give, then E value, E cell you can calculate. If E cell value is given, then K you can calculate, and this numericals are easy. Only thing is that you should know this relationship. You must remember. One numericals is there, very easy numericals I am telling you. Calculate the equilibrium constant of the reaction. Reaction they have given copper solid plus 2 Ag plus silver ion, that is giving Cu2 plus 2 Ag. This is the they have given the reaction, and also they have given a standard E value they have given, that is a 0.46 volt. Standard E cell value is given 0.46 volt. Then now see how it is easy, very easy. Here N, how will calculate the N? How will you calculate the N value? That is you have to understand. Okay. Then here N is equal to, if you see the reaction, balanced reaction, then Cu means solid plus 2 Ag silver ion, 2 Ag plus, it is giving Cu2 plus. Cu is becoming Cu2 plus, and 2 Ag plus was there, when it will convert and it will give 2 Ag solid silver it will give. It means there is a 2 electron involved in this reaction. Cu is converting to Cu2 plus. Obviously, this is the only things you have to find out, how many electrons are taking part. Then 2 electrons are taking part. Hence, in the place of N in formula, in relationship or in equation, in the place of N you write 2. E cell is given. E cell is given how much? 0.46. 0.46. Then now easily you can calculate the log Kc, means 2 into 0.46, divided by 0.059. Correct? Cross multiplication by that way easily you can calculate 2 into equilibrium this thing standard Ecell value. You will do cross multiplication, then 2 into Ecell is equal to 0.059. That's enough. Log Kc. Then now log Kc is equal to just 2 into value you put 2 into 0.46 divided by 0.059. Then Kc value will become log Kc value will be 15.6 log Kc. Then now what will be the Kc value? Then anti-log of 15.6. From the anti-log chart, logarithm chart, you can find out the value. Its value will come 3.92 into 10 to the power 15. 10 to the power 15. Okay. Then this I have discussed relation between Kc and standard electrode cell, standard electrode cell or standard electrode potential. Now another relation I am going to discuss you. That relation is also very, very important. Actually, this type of relation you might have seen in thermodynamics also. Thermodynamics. Here what you are going to derive, then electrochemical cell, relation between electrochemical cell and Gibbs free energy of the reaction. Electrochemical cell and Gibbs energy, Gibbs Gibbs, Gibbs energy of the reaction. Okay, this is again very, very important relation. Here actually delta G, Gibbs energy is delta G, Gibbs free energy. Name itself is a free, means this available energy to do the work, that is called free energy, available energy to do the work. Correct? That is called free energy. Then whenever reaction will take place, then that time it will release energy, chemical energy it is releasing. Then that energy actually is the free energy. That energy you can use for doing the work. Then always in a reaction delta G value has value. Delta G value is important. If delta G value is negative, if delta G change in free energy, delta means change means reactant minus product minus reactant. Product minus reactant. What is the value for energy value for product and what was the value for reactant? That difference is called delta G. Delta means change in free energy. That energy you can use for some work. Then here in any reaction delta G value has meaning. If delta G value is negative, then reaction is spontaneous, means reaction will take place by own. And why it will be negative? Because negative means what? Product, energy released by product that is less and reactant value was more. Reactant free energy was more, reactant energy was more, product energy was less. Then product minus reactant, if you will do, because reactant was more, hence you will get value minus. That is a spontaneous reaction. Spontaneous, it is releasing energy. Product has less energy, quickly it will change. But reverse case it will not, non-spontaneous. Reverse case product will be more and available energy is less, reactant side energy is less, then it will be positive, then reaction will be non-spontaneous. It will not take place. Then a spontaneous reaction, delta G value, E value, both are inversely related. E value should be positive, E, correct? And delta G value should be negative. Always you remember. Now means electrode potential value should be positive, and in term of free energy it should be negative. Always you remember these two things. Okay. Then now this relation, how will you get this relation, that I am telling you. And what is the relation, that also you will come to know. Just like what I derived now, relation between chemical equilibrium and chemical equilibrium constant, and Ecell was very easy, because easily main thing is that at equilibrium position Ecell value became 0. That's enough. Then 0 is equal to a standard minus 0.059 divided by n log k. That the relation you got, and then equate it. That's why that was the relation. Very easy relation. Now here also it is easy. This relation is easy. There you remember always that at equilibrium position Ecell is 0. Ecell is 0, that is equal to 0. After that quickly you will equate it both sides. Correct? But here is also not difficult. Here also it is easy. Only concept should be clear. What is the main things here? Now I am telling you. Listen carefully. Electrical work done in 1 second. Electrical work done in 1 second is equal to electrical potential multiplied by total charge passed. This always you remember. Electrical work done in 1 second per second, electrical work done per second in 1 second is equal to what? Then electrical potential into total charge, okay, total charge passed. You have to pass the charge, then electrical potential into total charge passed means multiplication. Simple formula, it became electrical work done, that is equal to potential into total charge passed. If we want to obtain maximum work from a galvanic cell, then charge has to be passed reversibly. This is the condition. Okay, if in a galvanic cell you want maximum work, if you want to obtain maximum work from a galvanic cell, then charge has to be passed reversibly. The reversible work done, now it will be called work done, will be called reversible work done, because charge you have passed reversibly. Then that time work is called reversible work done. Then reversible work done by a galvanic cell is equal to decrease in Gibbs free energy. Again, this is the important things. Work done, reversible work done by a galvanic cell is equal to minus delta G, decrease in Gibbs free energy, delta G minus delta G. This is the main, you can say, thing. Means W is equal to, you can tell, work done is equal to minus delta G. Correct? This is a very, very important relation I told you. Reversibly work done by a galvanic cell is equal to decrease in the Gibbs free energy, and therefore if the EM of the cell EM of the cell, that is the E. EM of the cell is standard I am talking about E. EM of the cell is E, and NF is the amount of charge. NF, 1 F means 96,500. F is equal to 96,500. Then you have to multiply by N, number of molecules or moles, whatever is there, N, number of electron you can tell. 1 electron is carrying 96,500 charge, coulomb, 1 electron. Then 2 electron, 2 into this, 2 into F, 3 electron, 3 into F, correct? That's why 1 electron is carrying that charge, 96,500, means exactly 487. 96,487. Then this NF, then E is equal to NF. E is equal to NF. Then EM of the cell, suppose EMF of the cell is E, and NF is the amount of charge passed, and delta G suppose is the Gibbs free energy of the reaction. Gibbs energy is for reaction, always remember. Then how all three are related? Delta G and this. Then delta G is equal to minus NFE. Already I have told you previous classes. Delta G is equal to NFE. Okay. NFE, standard E cell. Okay. Delta G is equal to minus NFE. This is the important relation. Here, actually here you should know, remember that E cell is an integer. These things, E cell, I have discussed these things, parameters like extensive properties, intensive properties. Intensive parameter, extensive parameter. Then here E cell is intensive parameter. Intensive. Okay, E cell electrode potential, standard electrode potential. But this delta G is extensive parameters or extensive thermodynamics property. Extensive means value will change, quantity will change, but whose value will not change, that is the intensive. Then example is the this thing, E cell, it is a fixed, standard E cell is a fixed. Then it is E cell is a intensive properties, and delta G is extensive thermodynamic parameters, and this value, delta G value, it means if it is a extensive value, delta G extensive value, means its value will change. It is not fixed. Then its value depends upon, now I can say, 3 factors. E value will be fixed, standard E will be fixed. Then now it depends upon the, you can say, N, how many number of electrons are there. On that value it will depend, and F value is fixed, E value is fixed. Then according to the N, if N is more, then more delta G value will be more. If N is less, delta G value will be less. Okay. Then for this Daniel cell, Zn plus copper cupric ion, that will give Zn2 plus copper. For this reaction, what will be the delta G? Then delta G is equal to, now number of electron is how many? 2. Zn is converting into Zn2 plus. Then in this reaction, or in can say Daniel cell or galvanic cell, Zn copper, N is equal to 2. Hence for this reaction, means for the Daniel cell, delta G value will be minus 2 Fe. F Ecell. Okay, standard Ecell. Then see how delta G is changing with n value. But when we write the reaction, as for example 2Zn plus 2 copper ion and product side 2Zn plus 2 copper, means we have multiplied everywhere by 2. Then what will be the delta G value? Then now here 4 electrons are involving. For 1Zn 2 electron, then for 2Zn 4 electron. You have multiplied everywhere 2. Same reaction. Zn plus Cu22 plus, that is the Zn plus copper. You multiplied everywhere 2. Then 1Zn, due to 1Zn 1Zn means 2 electron was involved. Then 4 electron, 2 Zn means 4 electron. And so now same delta G value will come 4 into Fe, minus 4 Fe. Then see how delta G value is changing with n. That's why it is called extensive property. Extensive property means always you keep in mind its value is not fixed. Its value will change. Its value will change with other. Correct? But intensive means it is fixed. It is fixed. As for example, this E value, EMF value, standard EMF value is fixed. Then if already now we have derived the relation, that relation only. Then here, if the concentration of all the reacting species is unity, now condition I am telling you for a standard delta G. Then a standard word when you are going to use, then what is the condition to be called as a standard? Then if the concentration of all the reacting species is unity, then what will happen? Then here means E cell will become a standard E cell. E cell will become a standard E cell, and this will be actually delta G, standard delta G, that is equal to R, also a small r you can write for the reversal reaction. Then standard delta G is equal to minus NF standard E cell. E means E cell. Okay, standard E cell, because standard condition you are applying. Then this you got delta G is equal to minus NFE. But you have, means now you got the relation delta G and E. Then now you can get one more relation. What is that relation? Then now this delta G, standard delta G, you got the relation is equal to minus NFE, minus Fe. And here one more relation is there. Delta G is equal to, that is the RT ln K. From the measurement of a standard E cell, we can obtain the important thermodynamic quantity delta G. Standard Gibbs free energy of the reaction. This standard Gibbs free energy of the reaction, you can get it from the, if E value you are knowing, E cell value you are knowing, then delta G value you can calculate. Okay. And also, how will you calculate equilibrium constant? From the equilibrium constant also you can calculate the delta G from the equilibrium constant. How? Then one relation is there. Delta G is equal to, standard delta is equal to minus RT ln K. minus RT ln K, that is equal to delta G. Two relation. One relation is, I told you, it is related to Ecell, standard Ecell. Correct? Delta G, standard delta G is equal to minus NFE. NFE, E means here standard cell. And other relation is delta G is equal to minus RT ln K. Two relations are there. Then now, again if you want, you can relate these two relations also. Because both are delta G. Both are delta G. One delta G is equal to minus NFE and other delta is equal to minus RT ln K. Then again in the place of delta G, minus RT ln K value can keep. Minus minus will be cancelled. Then you will get RT ln K is equal to NFE. But better you remember separate. Anytime you can equate. That is different things. You can do like this. Then you will get RT ln K is equal to NFE, means standard cell. Then this I have told you. Now one numericals is there, that is also very easy. Here I am telling you that in physical chemistry, main thing is there. In any chapter of physical chemistry, you should know the relation. If relationship you are knowing, formula you are knowing, then you quickly by seeing the question, if formula you are knowing, then you will be able to solve the numericals. Because other things you can think in mind quickly. Main thing is the formula. Okay, that whatever in that chapter, any chapter, what are the formulas, that you have to remember. Then any question you can solve. No, all question will be easy. It will look like tough, but quickly you can solve. If relationship you are knowing the formula. Now I am I will read the question. Okay, then you can understand the question. The standard electrode potential for Daniel cell is 1.1 volt. The standard electrode potential for Daniel cell is 1.1 volt. Calculate the standard Gibbs energy for the reaction Zn plus copper ion. That product is Zn2 plus copper. Means that reaction only have given. Galvanic cell, Daniel cell reaction is given. Zn solid plus Cu2 plus. Product is Zn2 plus copper solid. And for this reaction, you have to calculate a standard Gibbs free energy, means delta G. Then delta G standard is equal to minus NFE. And what is the problem? N is equal to 2, F is equal to 96,500. Correct? And E standard value is given 1.1 volt. Then how easy it is? Then now you put all the value minus NFE. N is equal to 2 minus 2 into 1.1 into 96,487 Coulomb per mole. This F value, that is Coulomb per mole. Okay. Then delta G value easily after multiplying you will get 21,227 joule per mole. This is the unit. Delta G unit is energy unit. Energy joule per mole. Now you will get after multiplying 21,227 joule per mole. If you want, you can calculate in kilojoule also. Just divide by 1000, then 21.227 kilojoule per mole. Okay. Then this I have discussed numericals. Now next class I will discuss conductance. Okay, conductance of electrolytic solution. Today it will take more time. Okay, next class I will start conductance of electrolytic solutions. Thank you.